Hello, this is Sing Ho. So this video is about my work on TinyChat optimizing large language model on edge device. So currently, running large language model on the edge is very important. However, despite their impressive capabilities, large language models have traditionally been quite resource intensive. So in this video, I will show a demo of deploying a Llama 2 7V chat with TinyChatEngine on my computer by implementing different optimization techniques like loop unrolling, multithreading, and embedding programming for the linear kernel. And also, I will show you the end-to-end latency improvement achieved by each techniques with the demo of TinyChat. So in this video, I will apply the technique that include loop unrolling, multithreading, SIMD, and combine them all together. Well, the reference file here is a standard for loop implementation that we can take as a baseline measurement to see how much we have improved by using each technique. And now let's first evaluate how does the reference implementation perform. And we can see that this is the time it took, and it's GOPS. Well, in the future implementation, we can compare the technique's optimization with this evaluation result. Well, we want to also test it on the chat engine to see how it performs. So here we load the model, and we can input something like, let's say, hi, and we are waiting for the response. Well, I probably need to speed up here, but I've put a timer here for reference of its speed. Okay, after almost 1 minute, which is quite a long time, we finally got a slow response from our chat assistant. Well, this result is really slow because we haven't implemented any technique to optimize the whole process. So now let's try using loop unrolling to optimize it. Well, the loop unrolling will reduce branching overhead at the expense of its binary size. To do that, we replicate the loop body a number of times and trade off between binary size and reduce overheads. And now let's evaluate its general performance. Well, we can see that with loop unrolling, we have a lower time consumption and higher operations per second. And if we test it on the TinyEngine again, I think the response should be much faster. Okay, let's say chat loop unrolling. And again, we are loading the model and we can say hi. And we are waiting for the response again. I guess I also still need to speed up a little bit to just get the answer quickly. And yeah, we did see that the chat speed up a little bit. Now we took only about 90 seconds to get a response from our assistants. And again, maybe this time we can ask another question here. Let's say, maybe can you introduce MIT to me? And we are waiting for the answer here. Okay, I think after another 19 seconds, we have a response from our model. And of course, Massachusetts Institute of Technology is a private research university, blah, blah, blah. Well, personally, I like this answer. It's not bad. And now maybe we can try another technique called multithreading. Well, multithreading is a concurrent execution of multiple threads within a single process. A thread is the smallest unit of execution in a program. With multithreading shared memory program, we make threads execute tasks at the same time, thus increase the overall speed. As thread can share a resource, it also reduces the overhead of creating multiple processes. It also makes the program remain responsive to user input. And again, let's evaluate. And we can just evaluate by adding the multithreading with the previous loop unrolling and combine and compare the result here. Okay, according to the evaluation result, the performance here was even better than singly used loop unrolling, and it has lower time usage and much higher GOPS. Because as I mentioned, the multithreading allows multiple threads execute tasks simultaneously, and as we're adding this 2-hour loop unrolling, it should be also performs better than purely used loop unrolling. And again, let's test this on our chat engine. Let's say chat, multithreading, loop unrolling. We're waiting for the model here. And again, we say hi. Okay, I think after only 8 seconds, we have an answer from the engine. And if we keep asking the MIT question, can you introduce MIT to me? We can hold and see. Yeah, it gives us a quick response. Yeah, and I think this really speed up a lot of here. And we actually can wait and see how long it can generate. Well, this is I think it's a perfect answer here. Yeah, and the result is fairly good if we combine loop unrolling and multithreading together. Oh, this is a quite long response here. And this comes to an end. Okay, we terminated this, and I think the result is so good, and the latency here is just not bad. Then, let's do another technique called SIMD and add it to our implementation. SIMD is a parallel processing paradigm that applies a single instruction to multiple data elements simultaneously. It specialized register that can hold and process multiple data elements, and it has an arithmetic and logical operation that works on entire vectors. With SIMD programming, we can increase computational throughput and speed and improve the energy efficiency. And let's again evaluate all techniques together by adding SIMD to loop unrolling and multithreading. Now you can see that the average time is far lower than the one without SIMD, and it's just much more lower than the reference one. And also the GOPS here increase a lot of times, like 60 times, I guess. And maybe again, we can test it on our chat engine and see how well it performs. And we say hi again. Okay. Well, I think the speed is really impressive. We actually didn't wait any time here. And again, we can ask a longer question. Still a very quick response here. And we can wait it for it finish the answer. Okay, so the inference latency here is just even better, like smaller. The count here is even larger, and we can just compare it to previous evaluation based on reference, loop unrolling, and multithreading. Well, when we employ all the technique that includes SIMD, it just performs much better. Alright, so here's the end. This is how I implement different techniques to optimize the large language model on each device. And for device information, here I'm using MacBook Pro with a memory of 32 GB. And the model we are using is Llama 2 7B chat with a 4-bit quantized weight reordering.